Okay guys, what is measurement? Measurement is a critical concept in quantum mechanics, right? But every term, every concept in physics must have a well-defined nature. So how we define measurement? Well, maybe let's see this experiment first and see how we do the measurement. Here in this part is a very common double slit experiment. You have a photon S, basically a tiny amount of light going through two slits. Then on the detector, you will see a interference pattern. If we measure the position of the photon before or at the two slits, then you will not see an interference pattern. You will see two stripes. Okay, cool. But how we measure the location of the photon S, though? We do a little bit trick. So here we have another photon, P, and P and S are entangled in a way that their polarization direction are perpendicular to each other. So light, photon, can be polarized in a linear way or in a circular way. In a linear way means that the wave of the light can oscillate, in any direction, maybe horizontally, vertically, horizontally, maybe let's say X, vertically, let's say the Y direction, or any combination of the X and Y's. Okay, and in circular motion, meaning that it can oscillate, like this. So it can be oscillating in a right-handed way or oscillating in a left-handed way. Okay, so in this case, P and S are entangled and they are all linearly polarized, and in a way that their polarizing direction are perpendicular to each other. Okay, so for example, if P is polarized in Y direction, along Y direction, then S gonna be along X, vice versa. But before measurement, we don't know the polarization of S and P yet. Okay, if we measure the polarization of S to be X axis, then P will definitely be Y. Okay, but if we don't measure it, their polarizing direction is in superposition. We don't know. Okay, cool. So now what we do is that we add a quarter wave plate in front of each slit. Okay, this device is kind of a special crystal that changes the linear polarized light into circular polarized light. And given a photon with a particular linear polarization, one wave plate, for example, the red one, would change it to right circular polarization, while the other one, for example, the green one, would change it to left circular polarization. Okay, cool. Now we have a very interesting stuff. If, for example, we measure the polarization of the P on the detector to be X, okay, then we know that before the plates, the S is polarizing along the Y direction, right? So we know it's Y direction, and we know that after the plates, it becomes left. So then we know it went through slit 2, basically. So by measuring the polarization of P and S after they hit the screen, we can derive the information of which slit the S photon went through, because this plate is right before the slit. Cool. So, this measurement is not directly measuring the position of S, right? But rather giving us information to derive the position of S. Cool. One interesting factor is that we don't have to exactly measure the polarization of P and S, okay? As long as we put quarter wave plates here, the interference pattern disappeared. Okay? Let me say it again. The moment we put a quarter wave plates here, the interference pattern disappeared. Okay? We don't need to measure the polarization of P and S and write it down on paper or anything. No. Okay? We put the plates in, interference pattern disappeared because the information existed. Alright, now the weird part. If we add a polarizer here, Okay, the polarizer will change the polarization of P. The polarization of P will always be a combination of X, Y. Always a perfect mix, 50% X, 50% Y. Okay, so we basically erased the information of the polarization direction of P. Then what we will see? We will see interference pattern. Okay, we removed the information which can derive which slit the photon went through. Therefore, we see interference pattern. Okay, now even weirder. We put a delay here, maybe elongate this distance so that after photon S hit the detector, then the information of Y is erased by the polarizer. Okay, what we will see? We will see interference pattern. Okay, so let me repeat. At a very small time window, in a very small time window, the information existed. Okay, the polarization of Y and the polarization of X, of P and S existed. But we remove the information afterwards. So this is delay the eraser. We remove the information afterwards. Then what we will see? Interference pattern, as if the information didn't exist at all. Okay, so the problem is, where is the measurement? Right? So is the measurement here? Is the quarter wave plates? If the measurement here, why adding a polarizer made it disappear? If the quarter wave plates is a measurement, then we've already measured it, right? How can we unmeasure it? I mean, the definition is really weird. Therefore, I said that information is the key, right? I said in previous videos that information is the key. It's not about the so-called measurement. But we are here anyway. We want to define measurement because that's the term people usually use. Okay, so the quarter wave plates are not a measurement device. The detector is a measurement device, but it's merely a screen. Okay, it's just a screen. It doesn't measure the polarization of the photon particles, so to speak. So the glasses, the polarizer, the plates, the glasses are not a measurement, but something solid that blocks the photon are kind of a measurement device. Well, yes, that's what people usually say. People say, okay, it is a measurement when particles touching each other, or maybe there's an inelastic process. Inelastic meaning that there's energy exchange. Okay, the photon lost energy because it hit other particles or whatever. Well, the photon is just basically a electromagnetic wave. Maybe it give energy to other electrons, let the electrons vibrate so that the photon lost some energy, and there's some energy exchange. Therefore, you basically leaked the information after the energy exchange. That's one explanation. The other explanation is that we got to use irreversible markers, because they argue that here the information of polarization is reversible. It's kind of a reversible marker. Okay, you got to use irreversible marker. Well, actually, I don't buy that much, because you got to define what irreversible is again, right? For example, if we have a very, very, very complicated, sophisticated system, that even if I use my marker, my literal marker, to draw something on the paper, the system can replace every atom, every particle to the place where it was before, and it seems like it's reverted, right? So do you call that reversible marker? I mean, conceptually, you can replace every atom to be the same place it was before, right? So it's really hard to define irreversible. And because it's irreversible, they say, okay, it's definitely measured. If it is reversible, then you need to say whether the marker is reversed or not. If yes, then it's not measured. If no, it's measured. Well, this is a really complicated diagram. We don't have to have two blocks, because if the marker is not reversible, we are not gonna reverse it, so it's measured. So basically, all it says is that if there's information available. So again, back to the point. What is measurement? Measurement is basically having the information available or not. Okay, that's what I believe, because the photon, after the photon hitting the screen, it already gives the information to the screen. Okay, the direction of the polarization is already passed to the screen, so it's leaked to the outside world. But if you add a polarization film in between, then before the information got leaked to other molecules, to other atoms, it is erased. So what I believe what measurement is information available or not. But that's just my thought, as Richard Feynman said, he said, I think I can safely say that nobody really understands quantum mechanics. I agree with that. I mean, I'm a stupid guy, definitely not as smart as Feynman, but I think I agree. We understand the quantum mechanics in equations, but we don't really know why those equations are there and what the hell they are telling us and how this world really works.